Hi students, my name is Thirupathi. I am from Triple department. I am working as assistant professor in Marri Laxman Reddy Institute of Technology and Management. Today we are going to discuss AC to AC converter, that is also called as AC regulator. So why we are studying about this means, so practically this AC to AC converter, the work is it will convert fixed AC into variable AC without change of any frequency. And we know already we have a device of transformer. So transformer is also a device which will change a fixed voltage into a variable voltage. So we can make it step up, step down, and step down into step up without changing of any frequency. Okay, but here we are using AC to AC converter by using of power electronic devices. So here we have advantages compared to the transformer is a bulky size and its cost is more and its losses are more, and it will take more amount of the space. But when you come to AC to AC converter, it is also doing the same function by converting step up and the step down, but its space is very less. The cost of the power electronic device is very less. Loss is also very less. So due to that reason, we are studying about the AC to AC converters. So by comparing of the transformer and this AC to AC converter, transformers are bulky and their ratings are very high. So nowadays the power electronic device also doing the research for the higher voltages. So now we can use this AC to AC converter up to medium level voltages. Okay, so that's the thing we are going to learn about the AC to AC converters. Okay, so now see here, this is third unit of the syllabus for power electronics. So here we have some topics: single phase 2 ACRs in anti-parallel with R and R loads, derivation of RMS load voltage, current and power factor waveforms, and more modes of operation of triac and triac with R and RL loads, and numerical problems, single phase and three phase cyclic converter. But today we are going to discuss about AC to AC converters only. So we will see some applications of the AC to AC converters. Okay. So here we can see AC voltage controllers are employed vary the RMS value of the alternator voltage applied to a load circuit. An AC voltage controller is a type of thyristor power converter which is used to convert a fixed voltage, fixed frequency. Here we are maintaining again the frequency is fixed, but the voltage will be changes. So here you can see the AC input supply to obtain a variable voltage AC output. Okay, so the RMS value of the AC voltage and the AC power flow to the load is controlled by varying the triggering angle alpha. So how we are going to change the output voltage, AC output voltage, that is increment or decrement for step up or step down by changing of the firing angle. So the power electronic devices we have, so by changing of the firing angle, the output voltage will increase, otherwise it will be decrease. So here we can observe a small block diagram of the AC to AC converter. So here we are giving the AC voltage input with a fixed frequency, and the Vs is the voltage and Fs is the source frequency. And in between that we have AC voltage controller. So AC voltage controller, after doing up its function, it will give the variable AC output voltage, with fixed frequency. So that is about the basic points. And here we have some types of AC voltage controllers. So here the type in this we have single phase AC voltage controllers and three phase voltage controller. Okay, so we have single phase as well as three phase systems, and the single phase voltage ratings are around 230 volts RMS at 50 Hz in our country, and in three phase we have 400 volts and the 50 Hz, 400 volts and the 50 Hz. Okay, and here some applications we have. So the first one is about for lighting or illumination control in the AC power circuits. Okay, and the induction heatings. In the induction heatings also we can use it, and industry heating and the domestic heatings. So wherever we required the fixed voltage to variable voltage, by varying of the voltage, there we can use it. Okay, and transformer tap changing. So like a transformer, we can use this AC to AC converter. And the speed control of induction motor. So in the speed control of induction motor, we have a voltage control method. So by varying of this voltage, the speed of the induction motor will be changed. And another one is the AC magnet controls. And these are applications of the AC to AC converters. And we have an advantage is AC voltage control have high efficiency. AC voltage control have high efficiency and the flexible. If you take the transformer can't move that much easily. So we have to use a large transporting systems like trains, trucks, or cranes to lift the transformer. But this AC to AC voltage controller can carry easily from one place to the another place. Why? Because its size is very compact. So due to that, it is a flexibility and controlling is also very easy. Okay, so if we tap change a transformer, if we change the tap, the sparks will be produced. But here we can change the firing angle, we can change the voltage easily. Okay, so that is flexibility in control, and it requires less maintenance. It required less maintenance, but the transformer required maintenance regularly. Okay, and here we have only one disadvantage, that is while doing the switching operation, the harmonics will be introduced in the load side. Okay, so that is the only disadvantage we have in the AC to AC converters. So in this, first we are going to learn about single phase AC voltage controller with R load. So here first we will learn about the circuit operation. So if you see here, we have a source voltage Vs and the load R and two thyristors Vt1 and the Vt2. The both thyristors Vt1 and the Vt2 are connected in anti-parallel connection. And here if you observe, we have a waveforms. One is the source voltage waveform and the triggering pulses, that is gate current Ig1 and the Ig2 and the output voltage. Here we observe and the output current I0 and the voltage across Vt1 and the Vt2. Okay, and here we have to notice that instead of using of these two thyristors, we can use a single device, that is triac. So triac is also nothing but the combination of two thyristors in anti-parallel connection. So if you want to replace with these two thyristors, we can place the triac. That is the option we have. Okay, so here previously we studied and we know a single switch will be operated for only single pulse, either it is a positive pulse or a negative pulse. Okay, so here I am considering Vt1 will be conduct for positive cycle and Vt2 will be conduct for negative cycle. Okay, so see the function first. So if you observe here in the output voltage 0 to alpha, in the 0 to alpha, we not given triggered pulse for Vt1 and the Vt2, so that the output voltage is 0. At alpha, we given trigger pulse for Vt1. So when we given trigger pulse for Vt1, the Vt1 starts conduction. So Vt1 period is from 0 to pi. Okay, so at alpha we are giving triggering pulse so that it will start conduction from alpha to pi. So if you observe here, we given firing angle and it starts from conduction and up to pi it will be conducts. Up to pi it will be conducts. After pi, the negative pulse will be appeared across the Vt1. So the first thyristor will get reversed bias. So it will goes into turn off. So from pi to pi plus alpha, due to the reverse condition, the thyristor T1 will be turn off and T2 will be ready to conduct, but we are not given any trigger pulse for T2, so that from pi to pi plus alpha, the output voltage seen as 0. Okay, so at pi plus alpha, we given trigger pulse for the T2. Okay, so when we given firing angle to the T2, this T2 will start conduction from pi plus alpha to 2 pi. 5 plus alpha to 2 pi. So here we can observe when we are used two devices for the pulse in the rectifier system, the positive pulse will be in the positive region and the negative pulse is also in the negative region. But when you come to the AC voltage controller, means that AC to AC converter, these VT1 is conducted for positive pulse, so that we got the positive one, and V22 is connected anti-parallelly, so that it will be conducted for negative pulse, so we got in the negative. If we are given the firing angle at 0, we are given firing angle at 0, so the same output voltage is similar as source voltage, so where we are, when we are given the firing angle at 0 for VT1 and firing angle at pi for VT2, then the same thing, whatever the source voltage we have, that same source voltage will be applied across the V0. So by varying of the alpha, the output voltage will be changes. Okay. So this way we can change fixed AC voltage to variable AC voltage. Okay. And here we are considering the load R. So already in the previous class we discussed, in the R load, the V0 waveform is also like similar as I0 waveform. Okay. But the amplitude of the V0 and I0 will not same. Okay. So I0 amplitude is somewhat less than the V0. Okay. So if you observe here, this is the I0 and this I0 waveform is same as the V0 for R load. Okay. So that is already we known. And VT1, we have to see VT1 and the VT2. Okay. So if you observe here, from 0 to alpha, we are observing the VT1. Why? Because already we discussed at V0 to alpha, the output voltage is 0. So when the output voltage is 0, the supply voltage will be present across VT1 and the VT2. So that in the waveform we can observe the voltage across V21 is from 0 to alpha. Okay. So at alpha we given triggered pulse. So when we give a triggered pulse, then it starts conduction. Till the pi. So at pi, again the two devices will be in turn off condition. So when the two devices are in turn off condition, then across them the voltage will be presence. Okay, these we can observe. Okay, so the voltage across VT1 we can observe and the voltage across VT2. Okay, so the current path for the first VT1 is from supply to T1, T1 to the load to the supply. Okay, and next for negative cycle, it will start from minus V2, minus Vs to the load to again T2, the T2 to again the positive. So these are the current paths of the two thyristors. Okay, so this is the circuit operation of single phase AC voltage controller with R load. Okay, so next topic we are going to discuss single phase AC voltage controller with RL load. Okay, so here the circuit looks like similar as R load, but here the extra one is added, that is the L load, the inductor. And we know the basics of the inductor. So inductor is a device which stores the energy in the form of magnetic field, and this inductor have a property, that is it will not allow the sudden change of the current. Okay, so here if you observe, the output voltage and the output current are not similar. So in the previously we seen the R load, the output voltage and the output current both are similar, but here the output voltage and the output current both are not similar. Okay, so we will see here first operation. So let me see, the current will flow from the positive of the source to the T1. So we given a triggered pulse at alpha, so that the T1 is turned on and it starts conduction. So it allows the current to flow through the load RL and again to the minus. Okay, so while the current is passing through the load, the inductor stores the energy. Okay, so it stores the energy, still the device is in turn on. So at pi the device will be turned off. At pi the device T1 will be turned off. So immediately we are not turning on the T2. so that here the inductor will act as a source and it will circulate the current through the T1, so that it will also conducted for a some negative region. So that is extinction angle we denoted as beta. So still the energy of the inductor becomes 0, it's in conduction period. So up to pi to beta, it's still in conduction. So at beta the inductor energy is decayed to 0, so that the output voltage become 0. From beta to pi plus alpha, we can observe the output voltage is 0. So at pi plus alpha, we triggered the second thyristor T2. So now it starts conduction. Now the current path is from negative Vs to the load to the thyristor T2, again T2 the supply. Okay, so it will start conduction in up to 2 pi. At 2 pi, again the source voltage become 0. So when the source voltage becomes 0, then this inductor will be act as a source and it will deliver the energy. So again it starts conduction in a positive period from 2 pi to the beta. So this beta is an extinction angle. So when the energy of the inductor decays to 0, then the output will become 0. So this cyclic way will be continuous. Okay, so this is about the output waveform. This is the output voltage waveform. Now we will see the output current. If you see here, due to the property of the inductor, it will not allow the sudden change of the current. So it slowly increases. So when the output voltage becomes 0, it slowly decreases to 0. Again, when we give a trigger pulse, again it slowly increases, again it slowly decreases to 0. So this way we will get the output current. So due to the inductor property, the output voltage and output current are not similar. Okay, so output current will be respond slowly. So due to that, the waveform is not similar. And here we can observe the voltage across the VT1 and the VT2. So when we are getting output voltage is 0, then that source voltage will be appeared across the thyristors VT1 and the VT2. Why? Because the both are acting like as a open circuit. So that source voltage will be present across the two thyristors. So here we can observe the waveforms. So at pi, we given a trigger pulse for the two switches. We given a trigger pulse for a switch. So it starts conduction. So when it starts conduction, the source voltage will be appeared across the output voltage, okay, at the load, so that the voltage across the VT1 is 0. Why? Because the total source voltage will be present at load side and the voltage across the VT1 and the VT2 will be 0. So here we have a 0. Okay. So when we given trigger pulse for VT2 up to VT2, then again we will get some voltage across the switches. So when we are given trigger pulse at 2 pi plus alpha, again the 0 voltage across the two switches, again the source voltage will be present at output voltage. So this way it will be continuous. Okay. So in the place of these anti-parallelly connected two thyristors, we can use triac also. Okay. So by using of triac also, we will get the similar outcomes of the circuit. Okay. So these are the two operations of the AC voltage controllers with R load and the RL load. Okay. Thank you very much for today's class.